All right, welcome back to part two. Um, so we finished here talking about glaciers, and we didn't quite get to finish the section up in the last video. So we'll just finish up these last few terms and then move on to wind erosion. So drumlines again is when a terminal moraine is overrun by the glacier as it advances again, and it smooths out the terminal moraine, the till that was there before, smooths it out into much more of a rounded lower hill. Now, outwash is sometimes you might have kind of a glacier coming down gently, and it's not necessarily advancing because it has it's not necessarily advancing anymore because it's actually kind of starting to melt already, retreating. And so as it melts, there's little deposits of sand and gravel and other sediments that are in the ice that are actually washed out from underneath the glacier, and we call that water that comes out, we call that melt water. Simply a term that we use for that the water that melts out of the glacier. And then kettles are so sometimes you'll have, we generally think of the ice as pushing the dirt along, but sometimes the dirt actually becomes more than the ice, and you have bits of ice kind of caught up in dirt. When that happens, we have kettles forming, and that's when the ice actually finally totally melts. It leaves behind kind of a hole in the ground where that ice used to be. That's what we call a kettle. And when these kettles fill with water, we call it a kettle lake. I mean, it makes sense, you know. So anyway, so I hope that makes sense there. It's you have lots of dirt with a little bit of ice in it. The ice melts and the dirt caves in. You have a kind of like a pond or a lake without if it fills with water. And then the final thing about glaciers is this thing of the Ice Age, and I'm sure you've heard of the Ice Age before. It's the period of widespread glaciation in which nearly one-third of the Earth's land area was covered by glaciers, as is evidenced by many moraines, drumlines, and kettles found in temperate regions of the world. Now there is evidence for an Ice Age or something, but I don't know that we've done very well to to incorporate the Ice Age as I still have lots of questions about the Ice Age and how that fits with the Christian worldview. I don't think we've done very well at actually exploring this. There's theories, but I feel like we haven't done much to actually form a good timeline for the Ice Age and so on and so forth. Anyway, that's glaciers. Moving on to erosion by wind. We call these the Aeolian processes. Not to be confused with the Aeolians. Yeah, they're very good, but this is Aeolians with an E instead of an A. It's any type of erosion caused by wind. Wind can easily transport smaller loose particles like dust, silt, and sand, though it cannot transport larger rocks except to weather them. The thing there is that Aeolian processes, it's any kind of erosion that's caused by wind is part of an Aeolian process. And there's three kinds of ways that wind can erode. The first is suspension, or actually that it moves particles. First is suspension. It's when you have really fine particles, they shoot up into the air, they kind of stay up there for a while, and then eventually they kind of float back down, go very long distance. The second kind is called saltation, and it's when particles are lifted, but only for short distances, and then they're dropped very quickly. And this can be dangerous because in that process it can actually end up dislodging other soil or whatever that wouldn't have normally been dislodged by wind, and you have further erosion happening. And then the third kind is this is the kind you want to avoid. It's creep. Okay, I'm just kidding. But it's just a name here. It's when particles are too heavy to be lifted by wind, but the wind can still kind of push it along, and so it just kind of scoots along the ground. We call that creep. Kind of creeping along the ground would be a way to think of it there. All right. Okay, you can't see that. I'm sorry. It says erosion by wind. The wind bloweth away. Deflation here is the removal of loose particles of sand and soil by the wind. It removes the smallest pieces of sand. Yeah, it removes the smallest as opposed to larger ones. So sometimes in deflation you have all the sediment that can be blown away by wind and then what you're left with is what you call desert pavement, and it's the result of deflation over time, and it just looks kind of like this barren, rocky surface. There's not much soil there. It looks like kind of rocks. And there's a picture of this of some desert pavement in your text as well, so you can check that out. And now sometimes you might have what you call a blowout or a deflation basin, and this is shallow depressions formed by the wind where the sand constantly moves and shifts in areas with little vegetation. So there's not much to keep the sand or the soil there, and so as the wind blows, it essentially can form a depression. And you'll see these kinds of things, especially like in deserts, where the sand blows very easily. Now, one thing that's interesting is that when you do have these things happening, and they form a blowout, in that digs down underneath the level of the groundwater, you have an oasis happening, and I included in the background here, you'll notice a picture of an oasis here. And so then, again, so we're talking about the wind blowing things away. So sandstorms, two kinds of storms here that happen. Sandstorms, they're thick clouds of suspended silt. And oops, I forgot to change that. It's supposed to be typically carrying coarse sand particles and fine particles of dry soil. And the difference between sandstorms and dust storms is that sandstorms usually occur in deserts. Dust storms usually occur where there's drought happening. And dust storms only consist of fine soil particles called dust. Sandstorms can also consist of the more coarser sand. And then the wind also deposits some places. So now, where the soil is blown away from, obviously those regions are harmed. But the places where this soil is deposited then by the wind is greatly benefited actually, and it has potentials to grow lots of lush and good vegetations. Loess is a term that we refer to, or used to refer to that soil that the wind deposits. Again, other places. It's a thick layer of clay and silt that is deposited when a dust storm weakens and drops the soil it was carrying. The soil that ends up being deposited in another place, and deposited in another place. So it's essentially it's what was deposited in another place when Aeolian processes happened. Sand dunes are another common example of something that can, when it gathers in large amounts, and you have huge heaps of loose wind-blown sand, common in deserts and near beaches, and it forms around obstacles that slow the wind. So you have an obstacle here as the wind pushes over across. It has slows, and then it has to drop some of that sand that is carrying, and so it forms a sand dune. There's different kinds of sand dunes here. Maybe we'll end the video with this. There's crescentic sand dunes, sickle shaped, the most common, and it kind of has a crescent, and it points leeward or away from the direction the wind is blowing from. There's parabolic dunes, and there's just the opposite of crescentic dunes. Their point towards into the wind. And then transverse dunes resemble ocean waves and form in lines perpendicular to the direction of the winds. So if the wind is blowing this way, these parabolic or transverse dunes are forming exactly 90 degrees the other way. And there's a star dune, and I see we're out of time. So we'll stop for now. I'll touch back this later.